Okay, so here we have a series parallel circuit. So we have a parallel branch here, R2 and R3, and we have R1 in series with this parallel branch. And we're going to see if we can find these values for this series parallel circuit. So here it is required that we find R3. So here is R3. Now we have V3 and I3. So we can use V3 and I3 to find R3. And we're going to work using this triangle here. So here we have V up at the top, we have I, and then we have R. Put a split in between, so we have V, I, R. So if you're looking for R, you cover R, and we have V over I. We're looking for I, cover I, and we have V over R. If you're looking for V, cover V, and we have I times R. So we're going to use this triangle in some way to assist us. So here we have, we need to find R3. So we are looking for R3. So we're going to use this triangle. So we're going to cover R is equal to V over I. And we have the values V and I. So we're going to have this. So R3 is equal to V3 over I3. This is equal to V3 is 5 volts. So we have 5 volts divided by I3 is 1 ampere. So we put the 1 there. So we have 5 divided by 1, which is equal to 5 ohms. So we have R3 is equal to 5 ohms right here. So the next one that we're looking at is V1. So V1 is across this resistor R1. So we have V1. We're looking for V1. Now in a parallel circuit, we have voltage on this side is constant, but this R1 is in series with the parallel branch. So what we need to do is to apply the voltage characteristic of a series circuit. So in a series circuit, the voltage divide among the resistors in the circuit. So the voltage is going to divide among R1 and the parallel branch. So we have 15 volts here, and this 15 volts, since we have 5 on the parallel side, we need to know now how much is on the series side. So what we're going to do is take away 5 from 15 to leave us with the voltage on the series side. So what we are going to look at is that V1 is equal to Vt minus V3. Here, V3. So Vt is 15 volts minus V3. V3 is 5 volts. So V1 would be equal to, when you minus 15 minus 5, which is 10 volts. So V1 is equal to 10 volts. So now we have the voltage across here to be 10 volts, and this is V1. Now we now find V1. So what is I1? So I1 is here, right across this resistor right here. So I is equal to, based on the formula, if we cover I, it is equal to V over R, and we have V and we have R. So we're going to write that down. So I1 is what we're looking for, is equal to V1 over R1, which is equal to V1 is now 10 volts that we found before, 10 divide by R1, which is 5 ohms. Write 5 there. So we have 10 divided by 5 is equal to 2 amperes, since we're looking for I1. So I1 is equal to 2 amperes. So we can just put it right here. I1 equal 2A. Okay, now the next thing, we found I1, we can find I2. Now in a series circuit, the current is constant and we have I1 equal 2 ampere. Now this current split among R3 and R2. So what we need to do is we already know the current at R3, which is I3 1 ampere. So if this current split, this 2 ampere split among these two resistors, and 1 ampere is coming here, that means we need to have about 1 amperes at that resistor. So what we're going to do is to minus, so I2 is equal to I1 minus I3 to get the current up there. So that is what we're going to do in this little space here. So we have we're looking for I2. So I2 is equal to I1 minus I3. So I1 is 2 amperes minus I3 is 1 ampere. So when we minus 2 from 1, we have 1 ampere. So I2 is equal to 1 ampere. So here now we're going to write I2 equal 1 ampere. Now we found I2. We're now going to look for R2. So R2 is what we are left with. Now in a parallel circuit, the voltage is constant in the parallel branch. So if we have 5 volts here, it means that we should also have 5 volts up at this resistor here. So what it means is that we need to use this 5 volts up here. So we're looking for R2, trying to use this small space here. We have R2 is equal to V2 over I2. So here we cover R is equal to V over I. So the voltage, since the voltage in the parallel circuit is constant, we're going to use the 5 volts here. So here we have 5 divided by I2. So I2 is the current across resistor 2, which is 1 ampere. So we use 1. So this is equal to 1 into 5 goes 5 times 5 ohms. So the resistance of this resistor is 5 ohms. So now we have R2. So we now look for RT, the total resistance. Now RT can be found using the total current. Now in a series circuit, any current through any resistor is through the series resistor is the total current. So since the current flowing through this series resistor is the total current, we're going to use this current I1 plus the total voltage to find the total resistance. We're going to try and use a small space here to find that. So we have RT is equal to VT divided by IT, and VT is 15 volts, so we have 15 volts divided by IT, since I1 and IT is the same thing because current in a series circuit is constant, we're going to use the 2 amperes there. So we have 2. So 15 divided by 2, we are left with, put the equal sign right there, 7.5. 7.5 ohms, ohm symbol. So 15 divided by 2 is equal to 7.5 ohms. So we now found R3 based on what is required here. So R3 is equal to 5 ohms. V1 is equal to 10 volts. Here it is. I1 here is equal to 2 amperes. I2 is equal to 1 ampere, and R2 here, here's R2. R2 is equal to 5 ohms, and we have RT is equal to 7.5 ohms. So this is how you would go about calculating resistance in a parallel circuit. Well, this is how I do it for most of the times. Some persons will do the calculation in a different way. So I do it this way because this way is much easier for me. Thank you for watching. Please subscribe. Have yourself a nice time.